I would suggest that everything I'm going to show you is actually review, okay? Even what I'm going to show you can leave right there. Thank you, sir. Even when was she nice about it? Okay, good. Even what I'm going to show you right now, even though I'm going to introduce it as being something new, it's really not, okay? There'll be a couple of new words, but again, they're gonna correlate very closely with things we've already talked about this year. All right, what is the title of our new unit? It's called Rational Functions. Trinity, rational functions. A rational function, you've heard of it before. Absolutely. You guys have already been exposed to this a little bit in regular algebra class, okay? We're going to go a tiny bit further. But here's how you know you have a rational function. You have a fraction, and you have variables. So what do you notice in this example here? Do I have a fraction? Do I have variables? That makes it a rational function, okay? The word rational, how can you define something as being rational? Something that can be expressed as a fraction, right? So when I talk about rational numbers, if I asked you, is 5 rational? Blake would say, yes, it is, Mr. Picardo, because 5 is equal to 5 over 1. If I said, is 0.33333333333, etc., rational, you would say, well, yeah, it's a repeating decimal. Well, what's 0.33333 repeating the same as? 1/3. It's a fraction, right? Okay. 0.25. 0.25 is the same as what fraction? 1/4, right? So 0.25 is rational, right? So you have a rational function when you have a fraction with variables, hence the function portion of that, right? Hence the function portion. All right, so we're going to go through a number of little exercises here in order to put together a picture, okay? And trust me, guys, the picture is not going to be complete today, okay? We're going to use the tools from today to do some tasks in the coming days. But nonetheless, algebraically find the y-intercept. Well, here's what you should be thinking. The y-intercept is what? It's where a function crosses the y-axis. What do you know about every single point that is on the y-axis? It has an x value of 0. So to get a y-intercept, we plug in x equals 0, right? So what is f of 0? It's 0 plus 6 over 0 minus 3. So we get -2, right? So where does this cross? It crosses at -2. Okay, gotcha. That cool? All right. Guys, is that how I write a y-intercept though? Do I just say -2? No, how do I write a y-intercept? The y-intercept is a what? It's a coordinate point, right? So it should have an x and a y, right? So the y-intercept, the way I would write it, guys, is 0, -2, right? You gotta have an x and a y. Is that good? Okay. Guys, I want you to write down on your paper any fraction that is equal to 0. Write down any fraction that is equal to 0. Any fraction that is equal to 0. And I'm going to ask for the, ready? First, second, third. First, second, third. Oh, that's not going to work. That's okay. First person, second person, third person in each row. First person, second person, third person. So that doesn't work for the last row. What do you got? Okay. 0 over 0. Okay. Third person. 0 over 1. First person. 0, 7. Okay. Second person. 0 over 4. And I'll give you, well, Blake, you're kind of the third person. Give me a fraction that's equal to 0. 0 over 5. All right, so I have 6 different things here. I'm going to tell you that 5 of them are right and 1 of them is not. Does anybody want to venture to guess which one of these is not correct and why? Caesar? All right, you don't like this one. Can you give me the reason why? You're right, but why? Why did you exclude that one? Ilani? You're right, except if the numbers are 0. Yeah, you're right. Any number divided by itself is 1 unless the numbers are 0. Unless the numbers are 0. How's that example different from the other ones? How's that example different from the other ones? There is something different about it. The 0's in the denominator, and what do we know mathematically is very, very bad? You can't have 0 in the denominator of a fraction, right? Because think about it, guys. To divide something, you're seeing how many times something goes into something else, right? Well, if the bottom is 0, how many times does nothing go into something? Well, if you don't have anything, you're not dividing, are you? So dividing by 0 does not exist, right? So this can't be done. What did you notice about the 5 examples that are correct? The 0's in the numerator. So here's the deal, guys. An x-intercept, right? Give me another word for x-intercept. Root and 0. Okay? You're going to find these things when the numerator of your rational function equals 0. So for this example, guys, what is the numerator? X plus, in this example, x plus 6, right? So what do I want to know? I want to know 1n plus x plus 6 equals 0. Where does it equal 0? When x equals negative 6. Guys, if I was to graph that root, what would it look like? 1, 2, 3, 4, 5, 6. It would look something like this, would it not? Oh, sorry, wrong place. I got to go where? To the left, not positive 6, but negative 6. 1, 2, 3, 4, 5, 6. Right here. Bang. Okay. What did I just put on my paper? A point. What does a coordinate point have? An x and a y. So what is the root? Negative 6, 0. It's a point. I got to write it as such. Doing okay. All right. Everybody on your paper right now, write me an example of a fraction that is undefined. Now, give me any fraction that is undefined. Hang on. And I'm going to have, ready? The third person, the second person, the first person, the third person, the second person, the first person. Go ahead, Jelani. Jelani says 5 over 0. Caden. Undefined fraction. Talia. Oh, sorry, not Talia. 3, second person again. First person. That's you. No. 9 over 0. I'm going to agree with 5 of these. One of these I disagree with. We could do 1 over 0, right? So I could change that to be 1 over 0, right? So what do you notice about those 5 examples, guys? What is different here? The denominator equaled 0. All right, and so for this example, the value that is undefined is what? Is 3. This is going to be a totally different concept, Blake. It's going to be a totally different concept. How do I put something on a graph that can't be there? Think about that. Hazy, right? Like, this made sense because a y-intercept is a point, right? So putting that on my graph made sense, right? This root is a point, right? So putting this on my graph made sense, didn't it? But how do I put something on my graph that is undefined? How do I put something on my graph that can't be there? Well, this is the new thing of the day, okay? What we do is we create something known as a vertical asymptote. 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 Show me what a vertical something looks like. Right? So watch this. Hazy, you're going to like this. Is this point allowed to be there? No, because what's the x value of that point? 3, and that's no good. Is this point allowed to be there? What do you think? Am I allowed to have a point there? Yes or no? What's the x value of that point? 3. Is that allowed to be there? No. How about right here? Can that point be there? Why not? What's the x value of that point? 3. Can I have a point here? Why not? What's the x value of that point? 3. Can I have a point here? So any point that is where? Along this what? Vertical line. This is like a boundary, right? This is a boundary. This is like hot lava. Okay? You can't go here. If you go here, you've just created an undefined fraction. It's no man's land. Make sense? Okay. So, quick question. Can I plug it? Is 0 part of the answer? Am I allowed to have something at 0? Yes or no? Yeah. Am I allowed to have something at 1? Yes or no? How about at 5? Sure. How about at -3? Sure. How about at +3? No. So what's the domain? The domain is going to be all reals except I'm not allowed to be 3. All reals except I'm not allowed to be 3. Blake, you dig? Oh boy. All right, so on this next page, I'm going to take all of that information, I'm going to put it on the graph, okay? So here's what we know. We know that there is a root at -6. That's the root. We know that we have a y-intercept at -2. There's the y-intercept. And we know that we had a vertical asymptote at +3. Notice something, guys. Did I even graph my function? Have I graphed it yet? No, I've identified some key aspects of it, right? I've identified some key aspects of it. Making sense so far? Okay, let's see if this question makes sense. Here I give you a function h of x. It says algebraically, determine where this function is undefined, give me the domain, and find any vertical asymptotes. So think of the three things that I just asked you. Where is it undefined? Where are there vertical asymptotes? And what's the domain? Haven't I really asked you the same problem three different ways? Because to be undefined, what has to be true? The bottom of the fraction has to equal 0. But doesn't undefined mean I have a vertical asymptote? Yeah. And aren't those the values that are not in the domain? So really, I've asked you the same question three different ways. Okay? So to answer this, or to answer this, you just want to know where is the denominator equal to 0. So where is this equal to 0? This Picardo guy. He's a sneaky guy, isn't he? Picardo, this guy's sneaky. It's almost like he knew that this was coming up, and that's why we practiced factoring yesterday. Because in order to find the solutions to this, I need to factor it, right? How many terms do I have? 3. That sounds like a trinomial, right? But what do you notice about this term? It's a 2, so that makes it an AC method, right? So I need two numbers that multiply to be negative 12, that when added together gives me 11. What are the numbers? 12 and negative 1. Well, we know where to put those. 12 and negative 1. Got those. What goes in front? And you guys practiced this a lot yesterday. 2x goes in front, whatever this is. And then we have one more step. What was that one more step? You divide by a factor that's common to the factor if you can, right? Is there a factor common to this? 2. And is there a factor common in this? Nope. Now, I factored it, right? But I didn't want to just factor it. I wanted the solutions. So what do I do with the factors once I have them? Set them equal to 0. And so I have solutions of negative 6 and 1/2. Hey guys, really quickly, time out, freeze, stop. I don't, like I said the right phrase, but it doesn't really make sense in terms of the context of the problem. The solutions to this problem are negative 6.5. What does that mean when I say the solutions? The values that make this fraction what? Undefined, right? Because those are the numbers that what? When plugged into this, give me 0 on the bottom, right? So this is where I'm undefined, which means that these are the vertical asymptotes. So these are the undefined values. Or the vertical asymptotes. So when I ask you about the domain, when I say, hey guys, what's the domain? You say, guys, you say, Mr. Pro, you can have everything in the world. You can plug in anything you want. What? Except negative 6 and 1/2, right? As long as you don't plug in those, you're good. Doing okay? Of course. All right, so the only new concept so far today is the fact that a fraction is undefined and irrational when the denominator equals 0. What I'm going to do now, guys, is I'm going to go over 3 different review concepts that we're going to need for this unit, okay? 3 concepts that we need for this unit. Review concept number 1, compositions. Compositions are functions that lie inside of another function. So if I say, what is f of g of -2? Where do you start? Where do you start? How do you evaluate f of g of -2? Well, you start from the inside and work your way out, right? Because that's sort of like a set of parentheses. So what is g of -2? Well, what am I going to do? I'm going to take -2 and plug it into my g. Splendid. G of -2 equals -8. What are we going to do with that? Well, this is going to substitute for that, right? Because what does this statement say? It says g of -2 equals -8. So this g of -2 can be substituted for -8, right? Now I got to find f of -8. So I take -8 and I plug it into the f function. That gives me -15 over -3, which is equal to 5. Comprende? Remember doing that? How's this next one different? Because it is different. It's not the same. There's nothing to do inside, is there? It just says g of x. So I can't do anything. So what do I need to do? I need to take g of x and plug it into f. I need to take g of x and plug it in to f. Not equal to it. So if you think, Jelani, if you think about the last example, I said find g of -2. What does that mean? It means replace the x with a -2, right? Well, here I want to find f of g of x. That means replace the x with 3x minus 2. So this x becomes 3x minus 2, and this x becomes 3x minus 2. For those that really didn't like what I just did, look up here really quickly. Ready? This and this, correct? Got replaced with this. So this x became 3x minus 2. This x became 3x minus 2. So the g went into the f. Is that okay now? Do you see it? Right? I literally, Trinity, I literally took this and put it for this x here and for this x here. See it? Cool. So what does that give me? It gives me 6x minus 4 plus 1 over 3x plus 3. And we'll talk more about that concept in the next couple of days and why that's important for this unit. Everybody okay? Yeah, that's it. G1 and off, right? There's nothing to solve. We're done. Now, if I asked you for a root, you would do some work. If I asked you for a y-intercept, you would do some work. If I asked you for a vertical asymptote, you could do some work, right? Just like the first page. All right. Here I give you a function, and I ask you to find the inverse. Okay? Haven't talked about this in a while, so it's good to review. The inverse, I want you to think about swapping the x and the y. X's become y's, y's become x's. Does that sound familiar? X's become y's, y's become x's. That's our inverse. So do I have x's and y's in this problem? Yeah. So what am I going to do? Anywhere there's a y, I'm going to make it an x. Anywhere there's an x, I'm going to make it a y. So it's going to look like this. And then I need to solve for y. This is the tough part, guys. This is the tough part. This is the tough part. I got to solve for y. So I'm going to put this x over a 1, okay? What do I do when I have a fraction equals a fraction? Cross multiply. Yep. So I have y times 1 equals x times y minus 2. So if I say solve for y, what does that mean? That means get y alone, right? Here's the problem. I have more than one y, right? So give me an idea of something I might want to do. Say again? Multiply what? You want to multiply these two? These two, you mean? I got to get this y over here somehow. Yeah, I know. It's not easy, is it? What can I do with the x? I can distribute it. Maybe we should do that. All right, well, I'm not sure that totally helped me, but at least I can move the y over now, right? Because I have an xy. Should I move that xy over? So I have that. Are all my y's by themselves, though? No. So this is the trick to this one, Briggs. Do you see how both of these things have y's in them? Like a GCF, right? Could I take a y out of both of these terms? If I took a y out of both of those terms, what would I be left with? 1 minus x. Why is that good news? Because to get y by itself, all I need to do is move the 1 minus x by dividing, right? That's the inverse. All right, last review concept of the day. Last review concept of the day is this idea of even and odd. This goes back to our function unit. Same place where we actually did inverses, okay? Even and odd. Here's what you need to remember. An even function is one that looks like this. Or this. Or this. What do you notice about all three of those? They have symmetry. Symmetry to what? Symmetry to the y-axis, right? Okay. Here's also what you need to remember. If there's a point xy on an even curve, there is also going to be a point negative x, positive y. If this is xy, do you see how there's another one on the other side that's the same y position, but the opposite x position? This is the same y position, right? Same height, but the opposite x position. Same height, opposite x position. Cool? An odd function is one that looks like this. The way that I told you guys to remember an odd function, the test, was to take your paper and flip it upside down. And if it looks exactly the same upside down as it does right side up, it's odd. So does it look exactly the same both ways? It does. And your rule is the exact opposite of this one. If you have xy, then you have negative x, negative y. You want to see how smart you guys are? Watch how smart you guys are. Here's a function, right? It says f of x equals this. Well, what does this rule say? It says xy, it says negative xy. In other words, if I plug in x, I get y. If I plug in negative x, I get y. I get the same thing, right? So here, if I changed this x to be a negative x and I got the same exact thing, then it would be even. If I change the x to be a negative x and I got the negative version of this, it would be odd. If I didn't get either one of them, it would be neither. Okay? So that's exactly what I'm going to do. I am going to check to see what happens when I do f of negative x. What does that mean? It means anywhere there's an x, change it to a negative x. Test f of negative x. Okay, so I get that, right? What's negative x squared? What's negative x times negative x? Two negatives? Make a positive, right? So isn't this going to be positive x squared minus 8 over negative 4x? Is it exactly the same as what you have up top? Well, the numerator is exactly the same. The top's exactly the same. But what about the bottom? I have 4x and I have negative 4x. So the only difference is the negative 1. Isn't this and this the same, except this has been multiplied by a negative 1? Which means that this is not the same. It's not y, it's negative y, which makes this an odd function. Cool? That's it. That's our first